Okay, so now that we've spent some time creating all sorts of different landforms, now it's time to actually begin analyzing them. So in this video, you'll learn how to create a colorized elevation model as well as a colorized slope analysis model. And it's important to know that the type of geometry that you're analyzing is going to it's going to need to be scripted a little bit differently. So I've shown you how to create one from a DEM with contours, how to create a landform from height field, and then I've even shown how to start to texturize them. And so it's important to use these three examples because, like I said, the way you go about it might be a little bit differently. This one's a mesh, this one's a surface, and this is a bunch of strips of surfaces. So there's more than one piece, single piece, and then a mesh. Because, like I said, the way you analyze them is going to be a little bit differently. It's actually easier to analyze a mesh than it is a surface. And you'll see that later on, that it's just easy to kind of assign colors to a mesh versus a surface. You have to actually kind of begin to separate the surface into a series of kind of fragments. Like I said, it'll be a little more clear momentarily, but I will begin this process just kind of looking at a traditional landform so you get the idea, and then we can start to apply it to these more abstract conditions. So let's go ahead and reference our mesh into Grasshopper. Okay, so I can go ahead and hide this now. And in order to find the elevation or colorize the elevations and do the slope analysis, we are actually going to be analyzing the points that construct this object. Always kind of think of when we begin to analyze anything, it's really coming from the points themselves. Just think of the world as a giant, dense point cloud, and eventually you can start to create curves and planes from them. So what we want to do is take our mesh and deconstruct it. So I'm going to go to Analysis, Deconstruct Mesh, and you'll see that it's really kind of just made up of tons of vertices or points and these faces, and this is where we can even start to assign the colors. So I'm going to turn this off so we can actually see what we're doing. So you can see from this mesh that we have almost 500,000 points, which is going to be good. It'll give us a nice kind of dense resolution to this. If you ever want to kind of simplify it, we can show you how to do that as well. But for now, let's just go ahead and begin this analysis process. So for the elevation, we're really just trying to figure out, okay, what's the relative z coordinate with all the other ones. So we can take our vertices here, deconstruct them to get their z values. Okay? So from here, this is where we get to create a color range, because we're essentially just using all these in comparison. So I can now go to my parameters, input, and use the color gradient. So what I need to know is what the lowest point is, or the lower limit for the gradient, as well as the upper limit, or our high point. So basically looking at that range of z values. And then I also need all the z values. So I can just go ahead and plug this one into there for now. I can then go to Math, find those bounds, so basically finding my high and low points. So negative 14 and 26. This has been scaled down just so it's not outrageously big compared to these other landforms. And now I can deconstruct my domain. So now I can actually take those upper and lower numbers and get those separate outputs. So I'm going to put the start or the low point into this one, and then this upper one into that one. And I'm also going to change my color range for now. So I can right click, go to presets, and choose one of these defaults, or I can even create my own and customize it. So let's just start off with this one for now. So basically, starting from the left is going to be your lower ones, and to the right is going to be your upper ones. And now I can go back to my mesh tab, construct my mesh. So we aren't, again, really manipulating anything, we're just analyzing it. So I'm going to just, again, plug my vertices back into there, my faces back into there, and you'll see that it's got its own, I guess it doesn't have a colorize here, but now I have the option to enter the colors, which I'm going to use this color gradient for. And there you go. So now you have basically a digital elevation model of this. And like I said, it's good because now you can even start to create your own color range. So maybe you can, I prefer to right click on these. Maybe I go towards something on the white side. Ooh, it's starting to kind of lag a little. I always like to kind of use the cooler tones. Now I'm going to pick something in this magenta style. So again, you can have a lot of freedom in creating your height fields. And if you want to, you can even contour it. So I can always type contour just to kind of add some supplemental data to this. Oops, which one is this? Start point, that's fine. Direction, fine. And then the distance, again, it has been scaled, so I can use something maybe like 5 or 2. All right, so now I can even have a corresponding contour lines to go with this. Cool. So there you go. So again, it's very simple to do these elevation models. And I'll even show you that I'm actually going to just apply these other ones to it as well. So let's just, I'm going to go ahead and get rid of that. So in order to apply the surface, I just have to really kind of change or add a couple more things. So I may go to parameters, surface, set one surface. Again, hide this. And now I'm going to convert that to a mesh. So I'm going to go mesh from brep. Turn that preview off, this off. Now again, I've got that same kind of color gradient applied to that. And again, I'll just show you, you can even do it for multiple surfaces, right? So now let's hide this. So there is something when you have multiple that you do have to actually change a little bit. So they're all basically using their own individual z values. So that's why these different color ranges seem to be at every single peak, because they're really kind of analyzing each one of these individually. So the only thing we really need to change is our upper and lower limits, because it's essentially creating its own separate upper and lower limits for each one of those. So if I were to look at this z value, or so I'll still look at these points here. So they're all kind of got their own branches. So every time you see these kind of bars here, that means it's slightly different. So what I can do is go ahead and, again, I'll use these bounds themselves. I'm going to go ahead and just disable some of this for now so you can see it a little bit better. So I'm going to take these and flatten them from here, and now you'll see that I've got all of those ranges which go into there now. And now let's see what happens if I plug this back in. Okay, so now it's kind of understanding that, okay, that even some of these areas that have those highest values, they'll be registered in the correct color gradient here. So now you can again kind of see the difference where all I have to do is flatten this bounds input. If it does it, then it's kind of again registering each one of these strips has its own kind of high and low point versus the relative comparison with everything. Versus when I flatten it, it creates an actual more accurate result. Again, I can always kind of, if I want to have more kind of color into it, I can always drag that all the way over to there. So now you can have some really kind of cool representations for that. I'm going to show you another step with these height elevations. Again, it's going to use the same kind of properties, but just shown a little bit differently. So I've, again, have a surface here. Let's go ahead and reference this surface. So you'll notice right from the beginning of this is that if I want to analyze this, so where is it? In this case, evaluate surface. It needs some UV points, and so unfortunately when there's not an easy way to deconstruct these, so you actually have to do something a little bit different. You have to actually create panels from this, which starts to kind of create something a little more rigid instead of this kind of smooth color. So again, you'll see here it's just a nice kind of color gradient where everything's blending together. So I'll actually just go ahead and keep that there and just copy and paste it to show you the comparison of these two different kind of height field visualizations. So I'll just turn that off for now. And so it's something I've shown before in some of the other videos where I can essentially begin to create an ISO trim of it. So I'll use the surface. It needs the domain to understand it. So I'll go to domain, divide domain. So again, this is a way to kind of create a series of panels. I can, again, depending on the level of detail, yeah, I'm just gonna double it so that these are practically all squares. Depending on the detail, will give you various resolutions of this visualization. Right, so if I want it to seem kind of more rigid, I'll keep something like that. If I want to have something more detailed, I'll increase those values. So let's just keep it around this level. The other way, again, you can even use the Lunchbox plugin to do something similar. So it doesn't even have to be perfectly squares. It could actually be cells as well, which could be kind of an interesting way to analyze these. I'll show you that too, because it's basically going to take the same kind of information. So from here, again, I need to understand what is it that I'm analyzing. When you're using surfaces, it doesn't work like the mesh where there's like points on each corner. It really just needs a single point to analyze because it's just a kind of one-to-one relationship. So from here, I'll do area to find their center points. Right, so this is basically the same thing I'm going to do to analyze it from this previous step. So I can just go ahead and copy and paste this. And again, I'm going to use the center points to analyze it. And now instead of this kind of process, I'm going to create a display of these individual panels. So I can just go to Display, Custom Preview. The geometry are these cells. And then again, the colors are here. So again, it's going to give you the same kind of colorization, but now they're just in a series of panels, which again kind of looks interesting depending on the resolution. So you can see the difference it'll have if I do something at a much lower resolution, right? It starts to look a little more pixelated or rigid in that case. Again, maybe you kind of like the rigid form of this, but maybe you don't want to see all those outlines. If you want to do that, you could still convert some of this to a mesh and colorize those in the same kind of fashion. So I'm going to convert those to meshes. This is again a good way to actually bake them too. So I'm going to take this mesh, colorize it. So again, it's asking for colors. Just drag that into there. Oops, let's go ahead and actually graft both of these. There we go. So now I've got them all corresponding to that same color. Again, what's great when I do it like this, I can actually bake these onto here. So I've got it turned off and I can actually start to select them and they're all just their own individual colors, which is kind of cool. So even though you can't bake a surface with colors, you can always convert it to a mesh and bake it that way. And so again, you can see the difference between having something as a nice kind of blend of these colors versus something that looks more pixelated. You can again do the same thing. Oops, let's hide some of this stuff. I don't want to see my surface here. Is that it's all very kind of interchangeable. So again, I've got all those surface panels. I probably don't want to have to like subdivide these, else it's going to look really crazy. I mean, it could be interesting. Let's give it a shot. So set multiple surfaces. You're just going to start to understand that there's a lot of kind of subdividing happening with this, and it's probably going to be a little overwhelming for it, but it's worth a shot. Oh, I guess it just didn't like it, so never mind on that. So let's just go back to this one. So I want to show you how, again, you can, maybe you don't want to use that kind of built-in subsurface and you can use the Lunchbox plugin. So again, go to Lunchbox. Maybe you want it to look like these hexagon panels. So again, I'm going to use this. Again, the cells, instead of them being curves, we want them to be a surface. So I can always go to Surface and use the fragmented patch. Let's just see if there's, oh yeah, there's some that it really just doesn't like. So let's again just kind of, maybe we want to increase the level of detail. maybe it'll like it better that way. Actually, you know what, I'm not even gonna bother with the hexagon. Let's try the diamonds. I think these work a little bit better. Yep. But again, I'm gonna use different densities. Again, I'll give this an expression. X times 2 to double it in the other direction, so they're a little more kind of like that. And so now again, what's good about it is it's already got those as surfaces, so I'm gonna, again, combine them, so I'm just dealing with them one at a time. So I'm gonna go to tree, merge. Now I can turn this off, so I'm just dealing with one output instead of two. What's great about this is I can literally just take this and turn it off, and then I'll just plug it into this one to find the area. Oops, that's why that's so. And then I'll also replace it over there. So you can see it's actually handled it pretty well. Turn the preview on, so now I've got a different panel of colors instead of the original. And what's cool is, I mean, I can probably change this without there being too much lag, right? So that starts to look pretty interesting with all these kind of diamonds and a variety of colors. And so with the surface, you have a little more flexibility of like how you begin to create these color patterns, versus the mesh is just going to create kind of a seamless blend of colors. So that'll be it for the elevation analysis. What's great about it is that we're going to use pretty much the very similar workflow as we did for the elevation, but instead of analyzing their z values, we're actually going to analyze their normal directions, which again from the mesh already gives it to us. We've done the same kind of slope for some of those other scripts. It's now just visualizing it. So again, utilize this to create your elevation analysis for landforms or any other type of surface that you want to do it for.